CS5 CRT 17. Computer Security Part 8. Cryptography. Unit 2. Cipher Methods. Part 1. Substitution cipher. Cryptography, which comes from the Greek words kryptos, meaning hidden, and graphein, meaning to write, is the process of making and using codes to secure the transmission of information. To understand the fundamentals of cryptography, you must know the meanings of the following terms. Encryption. Encryption is the process of converting an original message into a form that is unreadable to unauthorized individuals. Decryption is the process of converting the ciphertext message back into plain text so that it can be readily understood. Plain text. It is the original message. Ciphertext is the encrypted message. Key, the information used in conjunction with an algorithm to create the ciphertext from the plain text or derive the plain text from the ciphertext. Decipher, to decrypt, decode, or convert ciphertext into the equivalent plain text. Encipher, to encrypt, encode, or convert plain text into the equivalent ciphertext. Cipher methods. There are two methods of encrypting plain text. 1. The bit stream method. 2. The block cipher method. Bit stream method. In the bit stream method, each bit in the plain text is transformed into a cipher bit one bit at a time. This commonly use algorithm functions like the exclusive OR operation, XOR. Block cipher method. In the block cipher method, the message is divided into blocks. For example, sets of 8, 16, 32, or 64-bit blocks, and then each block of plain text bits is transformed into an encrypted block of cipher bits using an algorithm and a key. Block methods can use substitution, transposition, XOR, or some combination of these operations. 1. Substitution cipher. To use a substitution cipher, you substitute one value for another. Example: Caesar cipher. The earliest known, and the simplest, use of a substitution cipher was by Julius Caesar. The Caesar cipher involves replacing each letter of the alphabet with the letter standing 3 places further down the alphabet. For example, a letter in the alphabet with the letter 3 values to the right. Or you can substitute one bit for another bit that is 4 places to its left. Example: a 3-character substitution to the right results in the following transformation of the standard English alphabet: 4AD, BE, CF, DG, EH, FI, GJ, HK, IL, JM. Within this substitution scheme, the plain text high would be encrypted into the ciphertext. KDL. This type of substitution is based on a monoalphabetic substitution, because it only uses one alphabet. More advanced substitution ciphers use 2 or more alphabets, and are referred to as polyalphabetic substitutions. To extend the previous example, consider the following block of text. Plain text of dvgijglnopkerstuvuksis. Substitution cipher 1 dvgijglnopkerstuvuksis of k. Substitution cipher 2 gijglnopkerstuvuksis of def. Substitution cipher 3 jglnopkerstuvuksis of dvki. Substitution cipher 4 nopkerstuvuksis of dvgijgl. The first row here is the plain text, and the next 4 rows are 4 sets of substitution ciphers, which taken together constitute a single polyalphabetic substitution cipher. Let us try to encode the word text. First, to encode the first letter in the word text, T, you substitute a letter from the second row. For T, take W from second row. To encode the second letter in the word text, E, you substitute a letter from the third row. For E, take K from third row. To encode the third letter in the word text, X, you substitute a letter from the fourth row. For X, we take G from fourth row. To encode the fourth letter in the word text, T, you substitute a letter from the fifth row. Now the cipher text is WKGF. Complexities like these make this type of encryption substantially more difficult to decipher when one doesn't have the algorithm and the key. A logical extension to this process is to randomize the cipher rows completely in order to create a more complex operation. Vigenera cipher. An advanced type of substitution cipher that uses a simple polyalphabetic code is the Vigenera cipher. The cipher is implemented using the Vigenera square, or table, which is made up of 26 distinct cipher alphabets. Table illustrates the setup of the Vigenera square. Let us look at one example. Key ka. Plain text hi. First, the key is C and plain text is H. So the first letter in the cipher text is J. The next key is A and plain text is A. The next letter in the cipher text is A. The next key is S and plain text is I. The next letter in the cipher text is A. At last the cipher text is JAA. The next cipher method will be in the next video. Thank you.